Hello.
Hello?
Yeah, can you hear me?
Yes, I can hear you.
Okay, so now what is the problem you face?
So I presented the code that I developed with you, and then my supervisor kind of embraced it, but then he advised that the satellite we're using it wasn't appropriate because it couldn't cover the entire study time from 2000 to 2022 because it's I think that satellite was launched around 2016 or 2015. So he advised that I
Modis.
use Modis Aqua or Modis Terra to do the temperature in the chlorophyll calculation and then do the correlation analysis. That could be simple, it would make sense to have the good results. So I just need to create a code to analyze the chlorophyll concentration between 2000 and 2020 using Modis, and also create the data set for analyzing the temperature trends between 2000 and 2020 using the same satellites.
Okay, so for that I think it's better to use the Modis because Modis temperature data is already available for the Modis temperature. Aqua temperature, Modis aqua temperature is already available. And now we talk about the Modis chlorophyll. Okay, so how we can easily create the Modis chlorophyll for getting the result about that. Okay, so but for the Modis have the another problem because Modis is not the good resolution. This pixel area is not, this pixel area is very high. Okay, so that's why it's another problem for the small water reservoir. When you want to apply the Modis, then you did not get the better map when you want to use the Modis. Okay, so this is the another problem. So let me check you some result about the Modis aqua satellite imagery for making the chlorophyll concentration, and then we talk about that LST because Modis
Mhm.
LST is already available. There is no problem. But when you want to work with for that chlorophyll concentration, Modis is also available. But this problem is that only for the resolution. Modis aqua resolution is that 1000 meter pixel area, 1000 meter. So that's why when you want to put this algorithm into a small water or water reservoir, then we did not get the proper pixel. So it is another problem. So I will show you some example for the Modis aqua satellite imagery to
So
identify about that uh, chlorophyll.
okay.
I try to open my previous code.
Maybe I can show you something I've been working on too because I've been trying.
Okay.
I tried. Yeah, I got some images and I also got some time series. Maybe I can share my screen and show
Yeah,
it to
you can
you.
share the screen. Yeah.
You guys see my screen?
Yeah, I can see your screen.
So for this, I use the bodies to get this results. So this is the monthly average chlorophyll A concentration over time in Lake Victoria. and between 2000 2005. So this is a kind of result that um, I need to have, and then I can easily get this by downloading the CSV file and extracting the original data. So I can now analyze this data against the temperature data. I don't at this time I don't really name the four images to display the IG bloom or whatever or the temperature map because that's gonna take time. I don't have the time right now. So if I can extract these data, the chlorophyll and the temperature data, and then analyze that to find a correlation between both, I can tell a story
Okay,
as to
so
how
now you
temperature.
already make the chlorophyll concentration. So now you want to get the temperature data for, then you can easily make the correlation. When you want to get the two times the chart, mainly
Mhm,
chlorophyll and also get the temperature data, then you can easily make the
mhm.
correlation. Okay, then it's okay, no problem. So,
Yes.
so now this code is already available for that monthly chlorophyll concentration. Yes.
Yes, yes, I got a call for it.
Okay, so in this time, we can simply go to the data catalog and search Modis Aqua LST, Modis Aqua temperature data. Simply search, or if possible, you can simply send me a code link. Then I also try to add this code with your with this code. Then we can easily at the same time we can get the two times reach chart. One is the chlorophyll, another is that temperature.
Okay, just a second. So you want me to send you this code the for the core view? You want me to send that
Yeah,
to
yeah.
you?
You can send me this code link. Then I try to add the temperature data with the chlorophyll, and then find. Then we can easily get the correlation after downloading the two times reach chart. You can easily use the Python, or if you want, you can also use the other. Then you can easily find out the correlation between that
Um,
chlorophyll and also temperature data.
so I just sent to you.
Okay, let me find. Okay, so in this time we already make this type of chart, and it we can get the data from the Modis Aqua, and from that you can get the chlorophyll A concentration. So in this time we just use the another data for doing that temperature. So basically it is the Modis Aqua temperature. So just I simply search here. Can you see my screen?
No,
Oh, okay, let me share my
let me see.
screen. Uh, okay, now can you see my screen? Yeah.
Yes, yes.
Okay, so I simply search here Modis Aqua, or simply go to the Modis. Then we can easily get all of those Modis product. We find out the Modis Aqua temperature data. So ocean deflectance daily, then cover data set. Then we can get that Modis surface radiation daily photosynthetic activity radiation, land surface BRDF, terra and aqua land aerosol optical depth, Moody's BRDF albedo, Moody's albedo daily, Moody's burn area monthly, terra atmosphere monthly global dataset, terra surface reflectance 8-day global, surface reflectance daily, terra surface emittance, terra and land surface temperature, terra land surface temperature, terra vegetation.
So I was reading about the models to see which one could be preferable for temperature calculation. Um, the models acquired sea surface temperature is applicable, but the only condition is that probably it might not be very efficient for
Yeah.
lakes because it is said to be applicable mainly in the ocean, but it can still be applied. Maybe if we try, it gonna give some results. I think I developed something.
Okay,
Let me
what
see.
about this data? Aqua land surface temperature. Did you check it? Aqua land surface temperature.
The land surface temperature. So I also used that, but then what happened was it captured the entire surrounding and everything because I don't know why it is because it is land surface. So it didn't focus on the water using the ROI. I
Okay,
use a
okay,
click
okay.
function and everything. It didn't focus on the water. It rather like just randomly selected all the surface around the lake.
So we try to add that and then further we can check what happens.
But I think we can try the LTS. Yeah, we can try the LTS and see how it works.
Now let's check what happened. Okay, in this way I can get this type of chart, but it show the another unit. Mainly it show that you have to reproject it to the scale value. Then we can get the proper temperature time series chart about that. Okay, so let's go. We try to add the reproject the scale value for LST. Okay, so we have to write this function in here. So for that, I'll just use that the function image. Okay, just return this image, multiply with 0.02, and I have to get the result degree Celsius. So subtract this value 273.15. Okay, this whole thing I am to connecting using the map function. So just use it the map start and also close in here. And further I have to use the copy properties. Is copy properties is image and apply it system time start and system time int. So now further check. So now we can get this type of time series chart. Okay,
Okay.
and it show about the 24.453 degrees Celsius. And this is your data for chlorophyll. Okay,
So yeah, the Monday average curve, the Monday average temperature over
yeah,
time.
it's the monthly average temperature. July,
Mm-hmm.
we can get the result fast. You can see about that July. Okay, month is the same, but date is different. It's not any problem because we calculate the monthly. Okay, and
Mm-hmm.
then August and also used August. You can see it's so the result August 15, but month is the same. Okay, so that's why it's not the problem. So now further from here, you can easily make the correlation. Suppose monthly and it's that chlorophyll and temperature. We find out the correlation. What is the correlation between the two data?
Yes.
Okay. So in this time, if you want, you can also use at that Google Earth Engine. You can use the Python. Suppose,
No,
yeah.
I don't have idea on Phantom. Absolutely. So I don't know. Can 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 it be done in Earth Engine as well, like to do the calculation and everything?
Okay. So in this time, you want to suppose you have it's a data set. So now you want to calculate the correlation between that two collection, mean two chart. Okay. So let me
Yes.
check. So I already make a correlation code. I try to develop these things in here. Suppose here you can see NDVI and LST correlation. So I try to develop these things with that LST and chlorophyll. Okay. So first I try to check the result. Okay. So in this time we try to do this type of things. Suppose here you can see this type of LST and NDVI make the correlation. Okay. So in this time we make the correlation between that chlorophyll and temperature. So let's go try to develop these things one by one. So basically it start from here. First of all, get the intersection between two images, the area of interest. So NDVI and LST. So in this time we have try to add in here other things. So just I simply copy. Okay, so NDVI and LST. So in this time we just try to make the AOI. One is that profile, and it will be, let me check. NDVI will be image. Yeah, two images. So we have to create the two images. So one image, in this time we have to convert the image. We have to create the LST and also create the profile image. So for the image, how we can easily create the image? So in this time we make the collection, but we don't make the image. So for that, in this time I try to add the image basically using the reducer. So just take a variable, suppose CSL image. I call this collection,
Mm-hmm.
and then I simply put here that reduce. I want reducer using Earth Engine reducer dot mean dot mean mean. Okay, so it's my one image I create, and it's clip with my study area, which is ROI. Okay, so I create the image for chlorophyll image, and also need the create for image of LST. Okay, so just I try to add the LST image in here. So just take a variable. Suppose I put the suppose LST image and call the LST. From here, I just make the reduce it. Use at the reduce function, Earth Engine reducer dot mean, and it's also clip with our study area, which is ROI. Okay, so now I can get the two images, chlorophyll image, and also get the LST image. So I simply put here that image. One image is the chlorophyll, another image for LST image. So just I use the same variable name LST image also in here. And I put this, it is stored in this variable. I put the variable name, suppose AOI2. Okay, so this is the one image for chlorophyll, and this is another image for LST. Okay, done. And now we create some random point. In this time, we get the 100 random points within this study area. Okay. So for that, create the random points. So just I simply copy the same variable name. Okay, so just I copy from here. simply copy, and further I just try to put in my code, put paste in here. So in this time we create some random points with our geometry. I think it will be our shapefile variable name. Okay. So in this time, geometry. Okay, so I try to put here that random points for within ROI. Okay. So now try to check what happened. Okay, it created some random point. Okay. It create this type of random point, you can see. Okay. So now this type of point extract the information for chlorophyll and also extract the information for LST and then make the correlation. So let's go try to add these things. After extracting these things, we are trying to okay, so it also okay, no problem. So now combine the two bands. So in this time we make the combine the two bands. So first I simply copy, make the combo between that two bands. So just we are doing this thing here, simply paste in here. So in this time NDVI it will be chlorophyll. So chlorophyll, NDVI select the NDVI band, LST select the LST band. Okay, then rename it NDVI and LST. So in this time, what is the NDVI? NDVI mainly it's a image or collection. Check NDVI. NDVI, I think it's a image. It's a image. Okay. So in this time, we also use the same way also in here in our code. So it will be image. So basically, I simply call the chlorophyll image. Chlorophyll image and paste here and select the band of chlorophyll. Band of chlorophyll mainly your chlorophyll band, which band you want to use in here. Okay, so this is the band about that. Chlorophyll-a. So just I paste in here. And further, I call the LST image. So add bands with LST image, mainly LST image, and paste here. And select the band of LST. Mainly in this time, this band will be LST day 1 kilometer. LST day 1 kilometer. Copy and paste in here. Okay, I put the rename it. Suppose I put the name one is that CSL and another I put the suppose EM. Yeah, I put rename it this type things. Combo. I just simply put the combo. The two individual band. I simply put the combo in here. Okay. So after doing this combo, sample the using the sample point feature. Okay. So just I simply copy from here and constant. Okay, it also copy from here the independent variable. And further we calculate the linear regression and coefficient. We find out that it list. Okay, just we try to copy and then try to run it. What happened? Okay. And then paste. Or we try to use the same name and then check what the result can got first or what the wrong can got. Okay, so in this time we can get this type of problem. It show the LSTD 1 kilometer did not match any bands. Available band STD 1 kilometer mean. Okay, we try to use it. LSTD 1 kilometer mean we try to use in here. So now try again. Okay, it's a chlorophyll-a mean. I simply use it same name. Now try to check. So now it make the correlation between the temperature and chlorophyll. So now it takes some time. Let me check what. Okay, we have to change the scale. Okay. So in this time, this scale value will be, I think it's a what is a quarter the 1000 meter. Okay.
1,000, yeah.
Okay. Now try again. What happened? Okay, it's done again. So you can get this type of result for that correlation. So in this time, we change the title. Okay, so for that, what can I do? So I simply change in here. Suppose I put the, I rename it. Suppose I say first of all C. I can put any name. I put the name suppose CSL, and I put the name. It's a TEM. Okay, temperature. So just I simply copy this name and further I just also paste the same name also in here. Okay. And further also put here, just change it. Suppose I put this name, also change in here. Okay, and further I also change in here between that. Okay. Okay. Okay, I put the title. I put this, it's a chlorophyll, CSLA, chlorophyll A. I put it's a temperature. So now we can get the proper chart. So it's the one way to find out the correlation. So in this term, we can get that positive correlation. So you can see we can get this type. We can say temperature. It's a temperature. It's a chlorophyll. And for this study area, we find out it show this type of positive correlation, because this it show the positive. So it means that where the temperature is the high, this region is also increase the chlorophyll A concentration. Where the region is the low temperature, this region is the low growth of chlorophyll A concentration. Okay,
Mhm.
so this is the one way to make this
That's the
correlation.
linear regression.
Yeah, it's called the
Method.
linear regression.
Oh, okay.
And this linear regression we can generate from this 1000 training point or sample. Okay, so in this term all of those point extract the information from the temperature and also extract the information from the chlorophyll. Okay,
Mhm.
and then further it create this type of linear regression line. We find out
Can,
the positive correlation. Yeah.
can you display the formula for that?
Okay, this formula is the y equal to mx plus c. So here you can see this formula is that mainly this formula we have to use here yx. We find out the coefficient and we also try to find out that linear regression. This formula is the y equal to mx plus c. So we calculated that xy variable of an array, and here we can find out that y. Okay, and then further we calculate the slope. Okay, so you can see slope add with intercept. So this is the formula, y equal to mx, m mainly slope. Okay, m
Okay.
mainly slope, x and add with intercept. Okay, so this is the regression line, y equal to mx plus c.
Okay.
Okay, this formula we try to use in here, and further we try to calculate this type of make this type of chart about that, and then it automatically this type of correlation can find out in here. Okay, so basically this is the process to make the correlation for between the, not only for that, you can also use it for ndvi lst or ndvi chlorophyll or ndvi temperature, anything. Okay, if you want you can also increase the point. Suppose in this time we take the random 1000 point. Okay, in this time you can see it create the 1000 point. If you want you can also increasing, suppose 10,000 point, or decreasing the point. Okay, then we also get the more better result about that. So you can see the random point. If you want you can also add here the random point value. In this time we take the e feature collection random points with our ry. Okay, so in this
How
time mainly
how do
it's,
we
yeah.
how do we know the total number of random points? Is it in the code?
So in this time, we did not put any kinds of things in here, but we also calculate these things. Suppose I just print random points size. Then I can easily find out that how much point is available for that. Okay, you can see 1000.
Okay, 1,000. Great.
Okay. So basically, this is the process about that. So I also send you the code. You also try. Okay,
Okay.
and I
Mhm.
hope you can easily get the correlation between the temperature and chlorophyll about that. But this visualization is
So,
not, it's not good, because the resolution is the 1000 meter, and when you will be
mhm,
apply the 1000 meter for the small area, then it's
mhm.
not show the proper pixel area. But correlation is also okay, no problem. In this time it not
Yeah, I
visualize.
get
Yeah.
I
Yes.
can use it. So this code now, I can just manipulate it, like just change the ROI, and they will give me
Yeah,
the
yeah,
same
yeah, yeah.
result for other
So you
water
can
body, right?
simply this change this ROI, then it automatically work for any other study area
What?
also. Suppose
Okay,
I want to show this. Oh, this is the lake. I want to simply decrease this thing. So it's my study area. It's my study area. So I simply drag in here. Okay, and further I just click to run. So now I can get this result for this water body. Mainly, what is the correlation between that temperature and also chlorophyll for
okay,
any water. You know, you can see it automatically created the 1000 point. Okay, and also show you the result for the, yeah, we can get this type of correlation. You can see, just change, click on here and change it, and you can easily get any water body between the temperature and chlorophyll correlation. About that result you can easily get. Okay, so
okay.
I will send you the code. You also try to practice. I hope you can easily get this type of correlation chart also.
Yeah. Okay. Thank you so much.
Okay, thank you. Okay, have a good day. Okay, bye.
Thank you. Bye bye. You can.